Oh, hello class. Guess what we're doing today? No, well, you can read probably, so you know. We're going to be solving logarithmic equations. It's going to be a lot of fun, so let's jump in and do it. One of the things we want to remember, though, when we're solving logarithmic equations is to check for possible solutions. We want to check that they are real. There can be extraneous solutions, solutions that are not really solutions, and they would be the ones that produce a logarithm of a non-positive number. So if I put the number back in to the original equation and I have a log with a base of an argument, and that argument is not positive, then we're going to reject that solution. You'll see some examples like that. So we're always going to do this every time we're solving a logarithmic equation. Now, there are some different types of strategies. We're going to look at this first one, and these are the steps that if there are terms without logarithms. So we have some with logarithm and some that don't. So the first thing we're going to do is move all the logarithmic terms to one side of the equation. So that will be adding and subtracting some, on both sides of the equation until we get logarithms on one side and non-logarithms on the other side. Now on the logarithmic side of the equation, we're going to condense those logarithmic terms into a single logarithmic expression. Once we have that, with one logarithmic expression on one side of the equation, we're going to then write it as an exponential equation. So if we had log base b of m equals a, we're going to then rewrite that as b raised to the a is equal to m. And from that point, we're going to solve for the variable. Let's follow those steps and solve for x in this equation. So we've got log of x minus 3 equals 1 minus log x. We have two terms that have logs in them. So I want to get them on one side. I'm going to do that by adding log x to both sides of the equation. So I'll have log of x minus 3 plus log x is equal to 1. So then I'm going to condense this log side. So because they're being added, I'm going to use the product rule. So log of, and I'm going to go x times x minus 3 is equal to 1. Now I'm going to rewrite this as an exponential equation. Remember, our base is 10. So this is going to be 10 to the first power is equal to x times x minus 3. We're going to solve that equation. To do that, then we're going to distribute this x. So 10 to the first is 10, and that equals x squared minus 3x. Now if I subtract 10 from each side of the equation, that gives me a quadratic. 0 equals x squared minus 3x minus 10. And I can solve that by factoring. So this is going to factor into two binomials. X squared factors into x times x. And the factors of negative 10 that add up to negative 3 are negative 5 and positive 2. So we set these factors equal to 0. And we get x is equal to 5 and x is equal to -2. Now if I put this back into the equation, 5 minus 2 is, or 5 minus 3 is 2, and this would just be log of 5. So this one's good. This might be good too. Let's find out. -2 minus 3 is -5. And I can't have an argument that's negative, so I'm going to reject this answer. And my only answer is x equals 5. Once again, I have this little warning here. Always check for possible solutions in the original equation. We want to exclude any solutions that produce a logarithm of a non-positive number, like we had in that last example. So this is a different method because our equation is going to look a little different. All the terms are going to be logarithms, and they have the same base. If they don't have the same base, then we're not going to be able to solve for it in this manner. So if that is the case, though, the first thing we want to do is condense each side of the equation to a single logarithm. So now we're going to set the arguments equal to each other. So if we had something log with the base b, m, and that was equal to log with a base of n, the bases of these logs are the same, then the arguments m and n are equal to each other. And once we have it in that manner, m equals n, the arguments are set to each other, we're going to solve for the variable. So we have this example that we're going to solve for x in. Every term, this one, is a natural log. Natural log of x minus 3 is equal to the natural log of 7x minus 23 minus the natural log of x plus 1. So let's condense these. The first side is already condensed. It's only one logarithmic term. So I'm just going to keep it the same way. And that's equal to, and this will be one term with a natural log. And I'm going to use the quotient rule because I have a subtraction there. So it's going to be 7x minus 23 in the numerator and x plus 1 in the denominator. So now I have a natural log of something equals the natural log of something else. So those arguments can be set equal to each other. So x plus 3 is equal to 7x minus 23 over x plus 1. I'm going to take cross products now to start the solution. So if I take this side, 7x minus 23 equals 1, or times 1, I get 7x minus 23. And then on this side, I'm going to have x plus 3, or x minus 3. X minus 3. I have a little error there. Let's fix that. That should be a minus. So x minus 3 times x plus 1. 1. And I'm going to do the distributive property here. So I'm going to have 7x minus 23 is equal to, and first times first is x squared. Outside, x times 1 is 1x, and inside is negative 3 times x is negative 3x. So negative 3x plus that 1x is negative 2x. And then our last term is negative 3 times negative 1, or positive 1 is negative 3. So now I want to get these all onto one side of the equation because I have a squared unit, so I know it's going to be a quadratic. So I'm going to subtract 7x from each side. and add 23 to each side. So I'll have 0 equals x squared, and negative 2x minus 7x is negative 9x. And then negative 3 plus 23 is plus 20. And I'll factor that. And the x squared factors into x times x. And I need the factors of 20 that add to negative 9. That would be negative 5 and negative 4. So if I set those factors equal to 0, I'm going to have x is equal to 5 and x is equal to 4. And I want to double check. So each of these arguments, 5 minus 3 is 2, 4 minus 3, I'm sorry, 5 minus 3 is 2, 7 times 5 is 35, minus 23 is 12, and 5 plus 1 is 6. Those are all positive, so I can accept x equals 5. Let's check x equals 4. 4 minus 3 is 1. 4 times 7 is 28, minus 23 is 5. And x, or 4 plus 1 is 5. So all of those are also positive. So this does have two solutions, and I accept both of them. X equals 5 and x equals 4.